Hello friends, welcome back to the course on AMVI Mains examination. So we are discussing module number 3, that is theory of machines. So this is lecture number 9. So in previous lecture we have discussed one of the important topic, that is friction. In that we have seen friction in different bearings and screw jack. Now in today's lecture we are going to see different power transmitting devices. So we know that power is transmitted from one shaft to the other shaft by means of different devices like belts, ropes, chains and gears. So these are 4 devices which are used to transfer power from one shaft to the other. So इन चारों में से कौन सा डिवाइस कहाँ पे यूज होता है, ये अगर बताना है तो डिफरेंट क्राइटेरियाज है. लाइक फर्स्ट इज डिस्टेंस. अगर दो शाफ्ट में डिस्टेंस ज्यादा है तो वी कैन यूज बेल्ट्स, रोप्स एंड चेन. अगर डिस्टेंस कम है इन दैट केस वी कैन यूज गियर्स. अगर पहले 3 डिवाइसेस कंसीडर करेंगे हम, बेल्ट्स, रोप्स एंड चेन्स, वी कैन कॉल इट एज अ फ्लेक्सिबल डिवाइसेस. See, belts and ropes are flexible due to their material property, and chains, we know that chains are made up of number of small elements. The first 3 are flexible devices, whereas gear is not. Again, पहले जो 2 डिवाइस है belts and ropes, यहाँ पे पावर ट्रांसमिट होता है ड्यू टू फ्रिक्शन बिटवीन देम एंड पुलीज. सो वी कैन कॉल इट एज अ मोड ऑफ पावर ट्रांसमिशन, दैट इज फ्रिक्शन. जितना फ्रिक्शन ज्यादा होगा उतना पावर ट्रांसमिट ज्यादा किया जाएगा. बट इफ पावर ट्रांसमिटेड एक्सीड्स फोर्स ऑफ फ्रिक्शन, देन देयर विल बी अ स्लीप. यू माइट हैव हर्ड द वर्ड स्लीप ऑफ द बेल्ट्स. ओके, so as there is a friction, there is a slip. So we call belts and ropes as they not provide positive drive. यहाँ पे आप देखेंगे तो velocity ratio is not constant in case of belts and ropes. जो लास्ट वाले 2 बंदे हैं chains and gears, यहाँ पे velocity ratio remains constant and we can call it as a positive drive devices, or chains and gears provide positive drive. So there is one MCQ that which of the following devices provide positive drive. आपको 4 ऑप्शंस दिए जाएंगे like belts, ropes, chains and gears and none of the above. So chains and gears provide positive drive. Keep in mind. So let us discuss one by one. So first is belt drive. So to transmit the power from one shaft to another shaft, pulleys are mounted on 2 shafts and they are connected together by endless belts. That belt is kept into tension so that motion of input pulley is transferred to the output pulley. So यहाँ पे आप देख सकते हैं different types of belts like flat belt, V belt and circular belt. तो ये तीनों belts कहाँ पे use होते हैं? Like flat belt and V belts are used where moderate amount of power is to be transmitted, whereas circular belt is used where large amount of power is to be transmitted. And one more condition is that when distance between 2 pulleys is not more than 8 meter, then we use flat belts. When that distance is very small, then we use V belts. If distance is more than 8 meter, then we use circular belt. इसको हम बोल सकते हैं limits to use belts for power transmission, because if distance is increasing between 2 pulleys, then there may be a vibration. If distance is so small, then there may be a slip. So these are some constraints in power belt transmission. Okay, so let us see first flat belt. So we have seen different types of flat belts like open belt drive, cross belt drive, compound belt drive and cone pulley drive. So these are main types of flat belts which are used. Here one of the important thing is that the selection of belt drive is mainly dependent on velocity ratio, then power to be transmitted, then space available and service conditions. So based on these conditions, we can select different belt drives. So let us see one by one. First is open belt drive. यहाँ पे आप देख सकते हैं driver pulley is there, which is mounted on shaft A, driven pulley which is mounted on shaft B, and over these pulleys belt is mounted. So when to use this open belt drive? So it is used when driven pulley is desired to rotate in the same direction as that of driver pulley. So यहाँ पे आप देख सकते हैं driven pulley is rotating in clockwise direction which is same as that of rotation of driver pulley which is rotating in clockwise direction. अगर आपको दोनों शाफ्ट एक ही डायरेक्शन में रोटेट करने हैं तो then you can use open belt drive, and opposite to that there is a cross belt drive. If suppose we want driven shaft to rotate in opposite direction as that of driver shaft, there you can use cross belt drive. यहाँ पे आप देख सकते हैं driven shaft is rotating in anti-clockwise direction whereas driving shaft is rotating in clockwise direction. So due to this cross belt mounting we can get opposite motion. Also these two terms are appearing here, that is tight side and slack side. So we already told that there is a tension in a belt mounted on pulleys. Downward side is kept in more tension as that of upward side. So यहाँ पे आप देख सकते हैं slack side is there on top side. Due to this there is a sagging of belt on top side we can observe here, जिसकी वजह से क्या हो रहा है, angle of wrap, angle of contact is increasing as there is a sagging on upward side. Just consider opposite case that tight side is on top side and slack side is on bottom side. Then what will happen? There will be sagging or sag on downward side, so angle of contact will be less, so there are chances of slip in that case. That's why always tight side is provided at downward and slack side at upward side. Okay. Now third type is compound belt drive, where power is transmitted from one shaft to another shaft through number of pulleys. So यहाँ पे 4 pulleys use किए. So first combination 1 and 2. So where 1 will be driver, 2 will be driven. On the same shaft of pulley 2, pulley number 3 is mounted. So in the combination 3 and 4, 3 will be driver and 4 will be driven. So we can say that power is transmitted from shaft number 1 to shaft number 4 by using these intermediate pulleys. So generally to achieve large velocity ratios, this compound belt drive is used. And last one is cone pulley, where for a constant speed of driving shaft, speed of driven shaft is changed. So to achieve different velocity ratios, such a type of belt drives are used. यहाँ पे आप देख सकते हैं belt. So different cone pulleys are mounted on driving and driven shaft. So by shifting this belt, we can achieve different velocity ratios at constant speed of driving shaft. That is important. So such a cone pulley drive we generally observe in lathe machines. Okay, hope it is clear. Now next is velocity ratio of belt drive. So what is velocity ratio? So it is the ratio of velocities of driven pulley and driver pulley. As we are transmitting power from one shaft to the another shaft, we should know the velocity ratios of that two. So here velocity ratio is given as N2 upon N1 is equal to D1 upon D2, where N2 is speed of driven pulley, N1 is the speed of driving pulley, D1 is the diameter of driving pulley, and D2 is diameter of driven pulley. Okay. Next, velocity ratio of a compound belt drive. So simple belt drive में हमने देखा 2 ही pulleys है, उसका ratio simple था N2 upon N1 is equal to D1 upon D2. Now here 4 pulleys are there, so we have to consider velocity of each pulley. So यहाँ पे one is driver, which is driving pulley number 2. Pulley number 3 is mounted on same shaft as that of pulley number 2. Now in the combination 3 and 4, 3 is a driver which is driving pulley number 4. So ultimately pulley number 1 is driving pulley number 4. So 1 is driver and 4 will be driven. So final velocity ratio will be N4 upon N1 is equal to product of diameters of drivers. So here drivers are 1 and 3 divided by product of diameters of drivens. So here drivens are 2 and 4. D2 upon D4. If we consider both cases separately, like 1 and 2, 3 and 4, then so that ratio will be N2 upon N1 multiply by second case N4 upon N3 is equal to D1 upon D2 multiply by d3 upon d4. As 2 and 3 are mounted on same shaft, their speed will be same. So n2 and n3 will be cancelled. So n4 upon n1 will be, so this right side term will be as it is. So whatever number of pulleys are used in given compound belt drives, the formula will be speed of last driven to the speed of first driver is equal to product of diameters of drivers divided by product of diameters of drivens. Hope it is clear. Now next, slip of the belt. So we can say that it is a insufficient frictional grip causes some forward motion of the belt without carrying the driven pulley with it. So in simple words, बेल्ट जो है वो ड्रिवन पुली के आगे दौड़ रहा है because of insufficient grip. That is nothing but a slip of the belt. So the effect of this slip is to reduce the velocity of driven shaft. So you can see here velocity ratio we have discussed earlier, and here one more term is added which will reduce this ratio, and that term is 1 minus s upon 100, where s is s1 plus s2, that is total percentage of slip, where s1 is slip percentage between the driver and the belt, and s2 is the slip percentage between driven and the belt, that is driven pulley and belt. Remaining term as it is. So this slip will reduce velocity of driven shaft or velocity ratio. So that's why generally we try to avoid this slip. Okay. So next, the tensions in the flat belt drives. So as far as tensions in the belts are considered, so यहाँ पे एक formula दिया है. So many times we have heard this formula, T1 upon T2 is equal to e raised to mu theta, where T1 is tension in the tight side, T2 is the tension in slack side, mu is the coefficient of friction between pulleys and belt, and theta is angle of contact. But here one more type of tension is there, that is centrifugal tension. So we know that centrifugal means away from the center. So as belt is continuously running on pulleys, there is a centrifugal force present. So you can observe here Fc is the centrifugal force which is away from the center. As pulleys are rotating, centrifugal force present. Due to this centrifugal force, there is tension in the belt, and that tension is known as centrifugal tension, which is denoted as Tc, which is shown here. So generally at lower speeds, this centrifugal tension is small, but at higher speeds, the effect of centrifugal tension should be considered. So it is given by formula Tc is equal to mv square, where m is mass of belt and v is linear velocity of the belt. Now next is maximum tension in the belt. So we have seen T1 as tension in tight side, T2 as tension in slack side, and Tc as centrifugal tension. So maximum tension T will be given as tension in tight side because it will be the higher, plus centrifugal tension, that is Tc. So maximum tension is given as T1 plus Tc. So T1 is tension in tight side, Tc is centrifugal tension. ये जो value आएगी, that will be a maximum tension in given belt. Now this tension, maximum tension will act as a force. If we consider stress value, then the T will be sigma into Bt, that is cross section area of the belt. So if T is a force, force is equal to stress into area. So stress into area, that is B into T, where B is width of belt and T is thickness of the belt. So based on this formula, there may be small numericals in the exam which will be easy to solve. Okay. Now next is the power transmitted by the belt. अगर belt power transmission के लिए use हो रहा है तो वो कितना power transmit करेंगे, that we should know. Generally power is nothing but work done per unit time, which is also given as force into velocity. So यहाँ पे आप देख सकते हैं power is equal to force into velocity, where force is nothing but here it is net force, which is difference between tensions in tight side and slack side of the belt. So power is equal to T1 minus T2 into V, where V is the velocity of the belt. So this is how power is calculated. इसके ऊपर भी simple numericals रहेंगे. Okay. So next, condition for transmission of maximum power. So we have seen power transmitted by the belts. So maximum power कितना transmit होगा, that we should know. So अगर हमको maximum power चाहिए तो two things are there which should be maximum. So first is tension. Larger tension should be there, which must be equal to the maximum permissible value of the belt. And second is the maximum frictional force. अगर tension maximum है, frictional force maximum है, then and then only we can get maximum power. So in that case we got a condition, maximum tension T is equal to 3 times centrifugal tension. So we can say that to transmit maximum power, the centrifugal tension in the belt must be 1/3 of the maximum tension. This is required condition. Or we can say that 1/3 of maximum tension is absorbed as centrifugal tension. Okay. So if T is equal to 3 Tc, so we have seen maximum tension formula, T is equal to T1 plus Tc, then it will be T1 is equal to 2T upon 3. That is also important condition. And also one more important thing is that velocity of the belt for maximum power. So we have seen velocity in the formula Tc is equal to mv square. If we put Tc is equal to T upon 3, then maximum power at velocity v will be square root of T upon 3m. So यहाँ पे MCQs रहेंगे इन तीन conditions के ऊपर. Like for maximum power transmission, condition will be T is equal to 3 Tc, T1 will be 2T upon 3, and velocity of the belt for maximum power transmission, which will be square root of T upon 3m. Okay. Next is the angle of contact in case of open belt drive and cross belt drive. So we have discussed that in case of cross belt drive, this angle of contact will be more, and in case of open belt drive, it will be less. So in open belt drive, angle of contact, which is also known as lap angle, is considered at smaller pulley, which is important. So we can see here, angle of contact is from F to H, so which is nothing but 180. So this total 180 minus 2 alpha, alpha from this side and this side. So it is angle made by FO2 with vertical, where sine alpha will be R1 minus R2 divided by X. So theta will be 180 minus 2 alpha. If we want in radian, multiply by pi by 180. And in case of cross belt drive, angle of contact or lap angle will be same on both the pulleys. So here consider larger pulley, angle of contact is from E to G, which will be 180 plus 2 alpha, multiply by pi by 180 radian. And here sine alpha will be R1 plus R2 divided by X. So in MCQs either these formulas will be asked or the condition, means in open belt drive which pulley is to be considered for angle of contact, and in cross belt drive which pulley should be considered. So this is all about flat belt drive, and as per as RTO examination is concerned, most of the MCQs based on power transmission topic will be on flat belt drive only. So let us see overview of V belt drive. So some of the features, like it is suitable for short drives, V belt drive. This included angle usually from 30 degree to 40 degree. Compactness, positive drive, as slip is negligible. High velocity ratios can be obtained, so maximum 10 can be obtained. Belt life is greatly influenced with temperature changes, improper belt tension, and mismatching of the belt lengths. If there will be MCQs, it will be based on these points only. Okay. Next, features of chain drive. Important thing is that it gives a constant velocity ratio, and it is a positive drive. So it is used to transmit power when distance between centers of the shaft is shorter, as in bicycles, motorcycles, and agricultural machineries, road rollers, etc. So these are some of the applications of chain drive. It gives high transmission efficiency up to 98%. It gives less load on the shafts. So this is all about belt, rope, and chain drive. Now some of the MCQs based on today's lecture. So let us see which type of MCQs are asked based on today's topic. So first MCQs, when two pulleys of different diameters are connected by means of open belt drive, then angle of contact taken into consideration should be of, and options A, larger pulley, smaller pulley, average of two pulleys, and none of the above. So the question is based on angle of contact and that of open belt drive. So in earlier slide we have discussed that for open belt drive, angle of contact taken into consideration should be based on smaller pulley. So answer will be B, smaller pulley. So second, the velocity of the belt for maximum power is, so velocity is in the formula of centrifugal tension, Tc is equal to mv square, and for maximum power we have seen T is equal to 3 Tc. If we put this condition into this centrifugal tension formula, we will get velocity is equal to square root of T upon 3m. So answer will be C, square root of T upon 3m. Now next, which of the following are positive drives? And options, first is chain and gear drive, second is belt drive, third is rope drive, and none of the above. So in whole lecture we have discussed that chain and gear drive are providing positive drives. Therefore answer of this question is chain and gear drive, that is A, as it is giving constant velocity ratios, they are positive drives. Hope it is clear. So thank you for watching the video. If you like, you can share and subscribe the video. Thank you so much.